Well, good afternoon and welcome to this GIRI forum. I've got the pleasure of just introducing GIRI shortly so that to those of you who are less familiar with GIRI have got some idea of what we're about, and then I'll hand over to John to talk about the launch of our latest technology report. GIRI was founded back in 2015 following a meeting at the ICE best practice group, and we obtained funding to do some research into the cost of error, because at the time it was unknown what the cost of waste and error was to the industry. The result of that research was our strategy for change, and this is a resume of some of the cost reporting that we found. We used various methods to get these figures. The direct cost of error is 5%. This is the error that one might come across with NCRs and tablet records and things of that nature. So that's 5%. And then we have the indirect cost of error, which is the impact on other third parties, normally in the form of loss and expense claims or the like, but that came up at 7%. And then we have unrecorded process waste, which is at 6%, and this is errors which remain unrecorded. And latent defects come after the building or infrastructure has been handed over, and the total is 21%. Now, this depends on the complexity and size of the project. It may vary, but it's still an order of magnitude greater than the average return on turnover in terms of profitability. So the root causes of error we found, these were the top 10. Inadequate planning was top. There were 6 examples of different impacts from design, be it inadequate information, timing, communication. We then also had culture, financial and time pressures, inadequate supervisory skills. But our focus was on productivity, and this was our definition of productivity that we use. It's a combination of effectiveness. The efficiency is your output over input. So your material input or labor input is divided into the output that you are gaining, so many meters cubed per hour or something similar. Effectiveness is the quality or value of the outputs. So if you think of the quality or the specification that's decided, then it's important that effectiveness is achieved as well as efficiency, because you don't want to be efficient at producing the wrong thing. So this is where the productivity from GIRI comes into play. This was our strategic aim, to improve construction productivity. But we now know that our strategies to eliminate error are also beneficial to safety, sustainability, quality, reputation, and predictability. We've currently got 120 plus members covering the breadth of the industry, and this gives us a broad base on which to base our research and various proposals. So we've got our thought leadership role with our training, our framework, and our forums. We've got knowledge sharing through the research available on our website, communications at LinkedIn, and we have networking through our 4 meetings a year, usually at the ICE. The benefits, as I said, were productivity, safety. 37% of accidents occur during rework, so we've got something to go at there. Sustainability, well, if you're wasting materials, then time and money, your carbon footprint is not going to be very good. So quality is, I think, manifest if you're getting it right. More predictable outcomes and a better reputation. We've got various working groups, including the Technology Working Group. We've got Insurance, Building Safety Act, and a Metrics Group, all contributing to betterment of the industry. And we collaborate across the industry with other bodies seeking to ensure improvement in construction and its reputation. That's the end from me. I'm now going to pass over to John.
Thank you, Cliff. Hello, everybody. I'm John Priestland. I am a digital consultant, and I will echo what Cliff said in terms of GIRI. It's a wonderful organization and an environment. And the great thing from a digital point of view is error reduction is a completely unambiguous use case. You never get people saying, well, the thing is, we really think there should be more errors. So it's a cut through, and it's an organization and environment with very purposeful, like-minded people who are focused on bringing better value and better outcomes to construction. So I'm really pleased to be part of it. And today I'm going to talk to you about the document we issued on Thursday at the GIRI members meeting. Our second GIRI technology report, how to use technology to reduce errors in design and construction. Last year we produced a report. Hopefully my slides are clicking on, do say if they're not. Last year we produced a report that considered the types of technology that can help reduce error. This year we've come up with a much more practical report which goes through some of the best practice examples of where technology is really being used to reduce error. So I'm going to talk for a few minutes, but with this being a best practice casebook, we thought we should have some of the people who are doing the best practice. So we have 4 speakers who are going to talk for 5 minutes a pop, and they will hold to their time absolutely perfectly. And then that should, after a little bit further wrap up from me, allow us to do a little bit of Q&A. So our starting point goes back to some of the early days of GIRI and their iconic research report from April 2016, where they came up with 17 most prominent causes of error. And we linked that with work that we've done within the CTEC Club. And I say we, the CTEC Club is a group of more than 400 founders and CEOs of construction tech startups who come together to collaborate and share the celebrations and the commiserations of being a founder in construction. And we came up with 9 main categories of technology that linked to those 17 most prominent causes of error. So 2 diagrams to hit you with on the screen. The left one is from the GIRI 2016 report. These are the 17 most prominent causes of error, from inadequate planning, going anti-clockwise, late design changes, poor communication of design information, etc., through to poor site conditions and access. And then the wheel on the right is our CTEC Club 31 categories of technology, starting from number 1, top right, geotech scans, number 2, 3D visualization environments, all the way through to digital handover software, and the importance of this golden thread of how all the information comes together. So effectively, last year's report was a fusion of the 17 points on the left and 31 points on the right to come up with 9 categories of technology that make the greatest difference. So we can use technology to check, checking technology around BIM checkers, schedule checkers, data checkers, and checklist technology for our groups and teams on site. We can use technology to automate the generation of designs or scheduling. So a rules-based system that's going to get it right every time because it's applying the rules in the way the design is laid out or the schedule is laid out. Design configurators and automated scheduling systems being the 2 subcategories there. And then 7 more categories, workflow engines that are going to ensure that the steps between different stages in the process are managed well, and that there's no error in terms of who's coordinating and who's responsible for each step in that process journey. Visualization systems that with digital rehearsals help people practice before they go and do tasks on site to make them safer, more likely to get right first time, and the ability to visualize and see the tasks and the design environments in a virtual or augmented way before the task is undertaken in terms of virtual reality, VR, and augmented reality, AR. Then there's communication and collaboration tools, one of which you're going to see in a few minutes, that help people communicate better, have better structured conversations, so that the error doesn't come from the poor communication or the misunderstanding. Computer vision systems, which use a form of AI to infer meaning from images and video footage, which can be used to spot errors before they take place, or to spot them shortly after they've happened, so that they can be rectified quickly. IoT sensors, which will take data feeds from construction sites, for example, sensors in concrete that will check on curing time and make sure that there's no issue with the structural integrity of the resulting concrete when it comes out of the formwork. Digital setting out tools, which will lay out the outline of the building or the project with enhanced accuracy from what a human can do. And document management systems, or perhaps we might broaden that to common data environments, to allow people to work more fully on the right documents, on the same documents, and avoid some of that old style working where everything's in a yellow folder. There's no naming conventions, and people are confused as to what the latest version of a document might be. And as we put this report together, the 2024 Casebook report, we realized there were three other categories that were worthy of a mention. So we've also added, on top of those 9 sections and examples around quality management systems, around digital twins. We've got a couple of examples of digital twins in the report, and we make clear in each case what we mean by it. That can be such a universal and somewhat vague term, and forms and databases as well. So that's been the vision and the mission here. But to emphasize that it's not all about technology. We stress in the report, and the case studies absolutely bear this out, that what we're talking about is a successful blend and combination of people, process, and technology and information, and you're only as good as the weakest link. And often it's the information and the technology that do what you want, and the people are sometimes more of a challenge. And so we had a particular example in the report of a successful change management case study that's, I think, particularly interesting to go and have a look at. So let's hear from some of our best practice case studies. I'll introduce them very briefly before they go, and they will share their screen with you. The first one is a noise cancelling headphone by a company called Eve, which the case study featured in the book is Galliford Try Highways and the Grantham Southern Relief Road Phase 2. So David Greenberg, I'll stop sharing and hand over to you.
Thank you so much. So we've been working with Galliford Try Highways for about 5 years now, and the first sort of couple of years was really extensive education, awareness building across the organisation, and then culminated in a board level decision to change policy locally for what we do. While John introduced it as noise cancelling headphones, I'll say now that's not what we do. But at the same time, that is something that is where we started, and that is what Galliford Try really started layering on a lot of the understanding of what we do from that point. So we have developed the Evolution product range. It's part of our mission to prevent occupational diseases caused by things like noise, dust, and vibration exposure. It's a range of devices that work out in the field, in construction sites, from wearables to also environmental monitoring. So essentially what we're doing is personal exposure monitoring for noise, dust, and vibration, as well as environmental monitoring of noise, dust, and vibration, and a bunch of other things besides that. But tying it all together is the smartwatch in the middle. We have a partnership with Samsung, whereby their Samsung Galaxy watches are locked to the Eve ecosystem of devices and sensors, such that they provide the operative with information in real time, but also provide duty holders and managers of information of what's going on out in the field. And they get lots of sort of nice visualizations and maps. Just as a quick sort of snapshot of some of that, the watch is alerting the operative. It's also doing things like geofencing, location tracking, exposure monitoring, certification, all the things that you would want a smartwatch to do for a construction worker, it is doing. So you've got the health watch, which is assigned to an individual. You've got a tool warden, which is doing things like trigger time for power tool usage. You've got noise warden, which doubles as both a personal exposure monitor for noise as well as an environmental noise monitor. And you've got air warden, which does things like particulate matter monitoring, so dust. Obviously, people are worried about silicosis and silica exposure as well as asbestos, but it also does VOC, so volatile organic compounds, so gas exposure when you're doing excavation or demolition work. There's always a concern about particulate matter in the airs and gases. And so all of these devices are part of a connected ecosystem that mean that from a single place you can monitor and manage all of those hazards for health and the environment in one place. And this is the device that we started with, the world's first smart ear defender, which gives wearers situational awareness, so you can still hear what's going on around you while being protected. It also allows face-to-face communication while also tracking if it's being worn correctly, giving the operative information that they need to make sure that they're actually protected from noise in the first place. It's a total end-to-end ecosystem, so you've got devices in the field, the data goes from the edge to the cloud via those gateway devices, so the watch, the phone, and the smart tub. It connects into whatever platform the construction managers might be using. For example, Power BI is a very, very common one, but equally they have access to their own proprietary dashboard of information for their company. And that is it. Thank you so much. It's been a pleasure, obviously, working with the team at GIRI and also with Galliford Try over the years. We often try out some of our new things first with Galliford Try because they've got that sort of forward-thinking mentality, which is fantastic. But if anyone here would like to find out more, then feel free to make contact. Thank you so much.
I love what David's doing because he's moving on from the ear protectors into a whole range of other safety-related and environmental systems, and we are pleased to see that that's what successful startups are doing. It also shows that a safe project is one that's likely to be environmentally well managed, and one where the error reduction, the quality is going to be high as well. And I think it's the ability for workers to be able to communicate in the normal way that we saw as particularly linked to error reduction. But thank you very much, David, for all of that, and well done. Slightly bizarrely, our next technology product that we're going to share with you is also called Eve, spelled slightly differently. Who would have thought? So our next project is a project which is EVE, Engineer, Visualize, Explore, which is a tech system developed by Maybe Hire. And the example that John Wrigley is going to talk about is for the contractor John Leslie Limited for the Scottish Water Renewal Project at Happenden. I'll just sort of emphasise as I hand over to John, what I think is very pleasing is to see technology and error reduction and quality really being used in the field. This is not abstract, this is for real, and the people here today are able to share what it's actually like on the ground. So John, over to you. Share your screen and take EVE away.
Thank you very much. EVE stands for Engineer, Visualize and Explore. I'm John Wrigley from Maybe Hire. We're delighted to be part of the technology report this year. So we've used this innovation to essentially cut out mistakes from the planning stage through to actually delivery on site. So we can actually use it not just to make sure that there are no clashes, nothing can go wrong through the planning, but also right through to we can literally give an instruction manual on how it needs to fit together on site. And it's important to consider that temporary works are one of the 9 high-risk areas of construction process. So it's critical that temporary works are got right first time. So I'm going to show a short video in a minute. So Susan, if we could move on to that, which should demonstrate it better than I can describe it. I apologise for the music on that one. I had nothing to do with the choice of that. So if we go on to the final slide, it's important to point out that we as a temporary works company, despite having hire in our name, we also install, and we use this innovation ourselves. It helps us. It should help anybody using temporary works. And it gives the ability to get it right from the start, right through to the final delivery of the project, which we all know is critical. There's so many things that can go wrong throughout the construction process, and it really does get it right. So I think it fits the bill of GIRI perfectly.
Thank you, John. So it's all about the enabling the engineering design team to visualize the site context and provide that visual brief on what was to be excavated. So a little bit like a digital twin, being able to see what you can need to do beforehand, and then it's easier when you go and get it right first time. So our next presenter, as David Burton knows, one of my favorite projects. This is a project that Asbuilt Digital put together in Adelaide. Imagine the challenges of refurbishing the cladding of a building, which panel goes where, what do you need to do, what sort of a database would you need to maintain an accurate record of who's doing what. So David, over to you to tell the audience here about your project with Hindmarch Construction, and take it away.
Okay, so digital twins. I think John likes the practicality of what we've done here. Digitization in construction, for us, a lot of the focus traditionally has been on converting real bits of paper to digital bits of paper. For us, it offers a whole lot more. This user case here, we use the term digital twin, and I guess that gets banded around so much in our industry. But what does it mean, especially during construction? For us, it's really replicating what's happening in site, the milestone achievement and the workflow back into this digital environment. And what we've done here, I'll just refer to this because nothing paints a picture like, tells a story like a few pictures. Rather unfortunate name, this project. It was on Greenfell Street in Adelaide in Australia, and it was a replacement of the at-risk fire facades. What we were doing with the contractor and the supply chain on site is each time they did a task, they removed a panel, They installed the smoke seal, they installed the insulation, they completed it. All of those, that record keeping was done on the device. So really, at the heart of what we were doing, we were speeding up their workflow, removing the paper piece, and recording that almost as it was happening on site. Now, bless our lovely subcontractors, they don't always do what you want them to. And the first month they tried to cheat the system by uploading many of the same photographs. The system checks the metadata and says, hang on guys, that's not quite right. Try again. Another quite interesting thing to note on this project, once you start landing incremental data like this, it's not like your normal progress reporting where you get a viewpoint at the end of the week, end of the fortnight, or monthly. We were landing live status as it was happening. The other thing that we were doing is we were connecting it to the actual work package and how the subcontractor was getting paid. So not only was it a compliance QA thing, it actually affected how the contractor was getting paid, which I think drove the correct behaviour on both sites. More importantly, this term in the UK, I think the UK has been very good over the years of leading and mandating some change in our industry, back from some early health and safety stuff to mandating BIM, now this new health and safety legislation around golden thread. So I think it's very innovative thinking. And again, it drives the right behaviour of reporting and material and workflow provenance. How's that for time, John?
Very good. We're doing very well on time. So David, just let me ask you this question. So do you know sort of what happened next? So your subbies are told they're supposed to upload a bunch of photos to show panel by panel by panel that they're have done the replacement and they've added the necessary insulation behind the new panel. They think, oh, well, we can game the system by uploading the same picture 20 or 30 times. Your metadata analysis shows that A, it's the same data, and B, it doesn't have the right position, given you're effectively running a three-dimensional database. What happened next? Was it easy to get them to go and redo it? Were they kicking and screaming? Because I'm fascinated, as I said earlier, people, process, technology, and information. We're in the people and process part of this, which is always the most interesting.
Look, yeah, for us, it's not about the technology. It's about addressing the real industry problem. And for me, we were streamlining the QA process, making it visible to all stakeholders. That first month, I think we had about 400 duplicates. The following month, we had 2. So look, I think it's not just about compliance with the stick. You got to give both sides a win, and really, by organising that data and workflow into a three-dimensional database, like you say, we're doing away with a lot of duplication of effort, and at the heart, we're connecting the time, cost, and quality piece back to the three-dimensional database. So everyone talks about 3D, 4D, 5D, how amazing technology is, but what does it mean? How do we get our commercial team, our scheduling team, and the quality team aligned? And this concept of digital twin, another buzzword, has some amazing benefits for that communication and alignment piece.
Thank you. We'll go to our fourth team featured in the report now, which is the Heathrow Cargo Tunnel Replacement Refurbishment Project, which is being presented by Sam Hoff from Building Point UK and Cameron from Mace Group. As you'll see, they use some funky robotics and visualization tools and techniques, particularly to visualize inaccessible and unsafe areas. Over to you, Sam and Cameron.
Fantastic. Yeah, so thanks, John, for the quick intro. As Bishop quite rightly mentioned, so I represent Building Point in the UK, look after the construction arm of the Trimble distributor within the UK. So, you may be aware, some people on the call, if you've not come across Trimble before, you've got your Viewpoints, your SketchUps, all those sorts of programs. And then obviously we are the supplier and the supporter of Mason, ultimately Heathrow, in this rather interesting product that they have. But yeah, I suppose I'll hand over quickly to Cameron, who's going to walk you through what they've actually done on the cargo tunnel refurbishment project.
Yeah, thank you. I'm Cameron. I'm from Mace. And so we have implemented Dave the Dog, as well as the Trimble X7 scanner and Trimble Cloud Engine onto our cargo tunnel project, which, just to give you a little bit of background on what our project is, so it is a full systems overhaul of a 1960s asset to be compliant with current standards. Construction activities can only take place between the hours of 9 in the night to 5 in the morning before returning then to operational use, where we hand it back over to Heathrow Airport. It has quite a few issues, if you go to the next page. So the project is only accessible overnight, outside operational hours. Work can only be completed in high-risk areas in a lot of situations. And the cargo tunnel is also in a border-controlled airside environment, which poses a bit of a problem. We're trying to get people in and out of the site. So our reasoning for implementing the technology that we have is the challenging environment pretty much prompted the use of off-site construction methods where we could include it. And we really wanted to reduce the amount of people and equipment that we'd have to get through border control whenever possible. So implementing robotics and scanning would mean that we could get way less people onto a site in a high-risk area as well.
So what did we do? We implemented 3D laser scanning as it would support the reduction of people and equipment onto a high-risk and border-controlled site. And we chose this as, instead of bringing in a third-party survey team, we opted to purchase Boston Dynamics' Dave the Dog, or Spot the Dog, we just call him Dave affectionately, and the Trimble X7 laser scanner that we can actually mount directly onto the robot dog as a payload. So this will allow us to take scans of the tunnel, particularly in dirty or dangerous areas, to monitor site progress and to recognize any sort of errors that we may sort of run into. And we can use the scans to produce a model that's accurate. And we can then take this model and upload it directly to the Trimble tunnel station for setting out, which is quite useful as well. These scans actually enable accurate design. We can then obviously set out to enable accurate placement, and then we can use this to then verify and record and then double check that everything is as it should be.
What sort of benefits do we get from this? So using the dog and the scanner allows us to autonomously collect the scan data in high-risk areas while using less personnel to do so. Processing the data with Trimble Cloud Engine allows us to reduce human error. We can take the model that we've collected, overlay it with our actual model for the site, and create essentially what is a heat map. So it will be sort of colors that show how we deviate from our original designs, and we can obviously tweak it from there and get it to how we want it to be. We can also verify installations and surface levels to a highly accurate level with this. So this allows us to be more reactive. We're not so much reliant on subcontractors to capture data. It's all done in-house. The setup process is a lot quicker as opposed to setting up
Total stations
or doing all sorts of stuff with tripods. The dog is able to sort of ready itself and make sure it's able to basically do its job without having to keep setting up and then move and then set up. It's all done by the dog and the robotics on its own. This also is quite beneficial as less people are required for the scanning process. So getting through border process is a lot quicker. We only have 2 people and the dog, as opposed to a full surveying team for quite a large project. and this greatly reduces the amount of time that we spend on corrective works. And overall, I think the biggest benefit is we've seen a reduction of 7 weeks against all milestones where this technology has been used. And in a project like Heathrow, where each week can cost quite a lot, it's very beneficial. Speaking of costs, overall, it has worked out quite well for us, as Dave the Dog and the scanner has set us back about 158 grand, including training and equipment costs. Whereas opposed to if we had got a scanning team, the cost of a team for one night, on average for our project, would be about 2,500 for one night. And if we were to get weekly scans for 3 years, which is about the length of the project so far, it would cost a lot more than just using the dog and having 2 operators. This also has the benefit of being reusable, so we can use it on other projects, which we have actually been rolling out across the airport. So we've now used it on several other Mace projects. These are just some examples, and we're actually getting it onto another one as of tomorrow, which is quite nice. So it's definitely been very beneficial in that sense. So that's pretty much everything we've covered, unless you have anything to say, Sam?
No, I would just say that for me, Cameron, I think it's they're actually for Mace on this particular project, you targeted the actual problems right at the source. You know, you didn't have an accurate design. So what did you do? You found a solution that would enable you to build an accurate design, which then meant when it came to the design and the offsite manufacturing, that was all correct. All that needed to happen in those operational hours where you fitted it. And then the other thing is, you know, when you came to that fitting, you used Mace MEP as one of your subcontractors there to use the total station to set out directly, as it said it should have been in the model, in that right place. And then rather than using laser scanning right at the end of a project to say, that's wrong, and slap all your subcontractors on the wrist and say, you've done all this wrong and we're going to charge you X amount, you actually enabled them where that final laser scan was just proving that they'd done everything right. I think it really resonates the entire project with the entire Get It Right initiative. You know, we've started at the source of the problem, and we've addressed all of the potential causes of error throughout the project, to when the final check, all we do is say, that's grand, we've saved a lot of money and we've got it all right. I think that's all I can really add to that.
So thank you, Sam. Thank you, Cameron. What I really like about that project is people might decide to try and deploy robots or something else a bit cool like that, because hey, that's fun, or that's going to attract some attention. This is clearly very well thought out for a project with difficult nighttime working, with difficult confined spaces, and they proved with the figures that this has paid dividends. So we are particularly focused on the error side of things, and being able to visualize and see these things right first time is great. But we're also not about sort of digital vaporware and doing things because they look fun, which this team has clearly absolutely been doing the right thing for all of the right reasons and getting the benefits. So thank you. So a few more words from me, and then there will be some time for questions. So the purpose of what we've been doing with both the case study book and the presentation today is not saying these are the tools for your projects, but they're to give real evidence and grit, if you like, to the idea that digital tools are here, they're real, they're bringing substantive benefits in terms of error reduction and other use cases as well. So when you're choosing how to go and manage and run your project, we want to be giving you additional ideas for the digital tools that you should be choosing, where to go, what to buy, how those tools should link together. That's something we're going to be looking at in the next few months. We're going to think about whether each individual tool should continue to be in isolation, or whether we effectively need the toolbox that's going to help those tools integrate, so you go to one place and get access to a lot of tools, and you can get the data to flow between them, and whether there'll be additional reductions in error, improvements in quality, and improvements in efficiency of having these connection systems in place. And we're also going to be looking at the opportunities for the use of AI to reduce error, but also some of the additional pitfalls and problems of the possibility of using AI. Can AI itself actually potentially be a source of error? And how can the design of the way in which AI is deployed in construction maximize the positives and minimize the potential negatives? And I want to draw attention to the fact that the book was launched. It's available on the website, the GIRI website. That's me launching it last Thursday at the Institution of Civil Engineers. That's the link. I'm sure we can put that link in the chat. So please do go and download it, share it, use it. And if you've got examples of technology that you're using, then we'll be interested to hear from that. And indeed, I want to put a little shout out at the end to the GIRI Technology Working Group, which Cliff mentioned at the beginning, one of 4 working groups that GIRI has, and I'm pleased to be chairing that. I've written what we do here down as an equation. We bring quality managers and technology specialists together to share what's going on in the market, what technology can do, and potentially where there are unmet needs. So the group is about insights on best practice, as well as ideas for new tools and solutions. So the group typically meets last Friday of the month, 11 o'clock, a Teams call. We've had a variety of different topics that we've discussed. We had a session on big tech where we had Google, Procore, Microsoft. We've had a number of startups come and present. Last Friday, we had a special session around the challenges and opportunities for the use of technology for quality management in the nuclear sector, and 3 speakers, one from Hinkley Point C, one from Sizewell C, and one from Nuclear Waste Services and the Geological Disposal Facilities. So these are structured meetings that bring content from a technology and from a quality management point of view. So to find out more about the GIRI Technology Working Group, please contact admin@getitright.uk.com. And if you're a GIRI member and are interested in technology and quality, you'd be very welcome to join us. Thank you. And I will stop sharing my screen. And I think that does give us, on this occasion, a few minutes, 10 minutes or so for questions. Susan, maybe you'll direct the questions, assuming there are some.
So we just had one point in the chat from Chris Parry about reaching out, if they're interested in more data or contact with any of the case studies presented. And I think everyone would be happy to share their details, I guess. So I can be a kind of contact point if anyone wants any more information about any of the projects presented.
One of the nice things about GIRI, the work we've done with the book, and indeed today, is that this is collaboration in terms of sharing the highs and the lows, the benefits and the disbenefits. Nobody is in selling mode. So we're very clear in the report who has produced which project, and it's relatively easy to find out who to contact there for. But this is not a marketing document. These are not not the sort of entries that people put together for perhaps an award ceremony or an annual report. This is a GIRI view of the technology that's interesting to members and others. So just to sort of set the context as to why we've not got the all of the contact details lined up, because it's not primarily designed as a marketing document. But the good practice is definitely worth following up. Thank you, Susan, for agreeing to provide those details. Are there any other questions? Ema. Question about Dave the dog. And I'll add to that question for Sam and Cameron. I was thinking it was going to be Spot the dog. What's the relationship between Spot the dog and Dave the dog? Is there a whole family of different Boston robotic dogs, and he's responsible for the naming?
I think that while Cameron rejoins us, I think Dave.
Yeah.
Dave is a name that spanned out of when they first purchased. They ran an in-office competition for the best name. And from what I gather, Dave was apparently all they could come up with. So it's Dave.
Personally, I would have gone for something like Snoop, but I wasn't here at the time. Unfortunately, Dave won.
All of naming, I see. It's that sort of thing, is it?
Yeah. So it was just a obvious competition, like you said. But yeah, I think there definitely could have been a better name. But I think there is potential plans to get more dogs throughout Heathrow. I'm not certain on that, but there have been sort of talks.
To pick up on Ema's slightly less flippant question, did you find working with Dave easy and straightforward, or more difficult at the beginning?
Yeah, I mean, generally speaking, picking it up was pretty simple. The controls are very, very straightforward.
The only
real challenges are sort of, I guess, getting used to how the sort of, I don't know how to explain it, to be honest. My words are leaving me.
I think it's software. It's the hardware, and I think that's probably where we helped out Mace. Is that Emma there? We obviously work with you guys quite closely as well, but it's more sort of a training, upskilling of Cameron, for example. Cameron's not got that background, so it was more of a let's work and teach Cameron the basics of the methodologies of the instrumentation that we're putting together here. It's not as simple as go, press, point and shoot and it all works hunky-dory. You've got to understand a few of the founding sort of knowledge behind, what a laser scanner does, how it works, what problems it'll have, how do we get that onto a survey control? All those sorts of things we address through training. Communication-wise, connectivity, that's not an issue because it was running in full autonomous and still does. So we can basically turn the tablet off and throw it away. I wouldn't recommend throwing it away, though. It's quite expensive. And then did he always get it right? I would say no. I don't think Dave, that's part of the joy of being involved in the Get It Right initiative is, not everything always works perfectly. However, it's a damn sight more repeatable than getting a team to go out and do it, I would say. They're a damn sight more repeatable.
I think just to add on to that, there are cases where it might be better to do, I guess, the traditional approach to scanning, but where Dave is useful, he makes life so much easier. Because I've done a little bit of training for traditional survey, I guess, using a tripod, and the amount of time you save, the amount of hours that are saved, generally speaking, is really, really helpful to the entire process.
Very good. Well, Susan, Cliff, if there are no more questions, here's one. Ema's come back again.
Yeah, so Ema's asking on digital twin, the subby was originally mandated to use the tech. Did they come to view it as a benefit to avoid snagging lists and actually getting paid more promptly? So I think this is the as-built.
Yes. My favourite project, David.
Thank you, John. I think the biggest benefit to the subcontractor, so yes, they were mandated, and when you tell our subbies to do things, sometimes they don't like it, but ultimately they saw the benefit of no paperwork. So when they came down off the working platform, all of the QA was done, and they had basically exact backup records for all of their work. So every time they scanned something, that contributed to the work package. So yeah, look, the QA process was done for them, the backup for all of their payment applications. I mean, we could have automated payment daily based on their work if we'd really wanted to.
So Cliff and Susan, I think we'll thank all the presenters very warmly for their time and effort, not just today, but into helping produce the book. And there are 18 of them for presenting today. Thank our audience for their attention and their interest. It's a really pleasing turnout. Thanks, Susan and Cliff. And Cliff, back to you, perhaps to say the final word.
Well, as I've said to you before, John, I'm really impressed by the work that the GIRI Technology Group are doing and have done. And I believe that this type of research report with proper case studies showing, the real life situations is so much more useful to people on the ground than some of the more high-level academic evaluations of the construction industry and what's good for it. So I think this is right in GIRI's territory, and I thank you very much, John, and your team for what you produced again this year, and I look forward to your AI use cases for next year.
That'll be easy. I'll just get ChatGPT to write it.
Yeah, I thought you might say that.
Very good.
But I
Thank
think
you,
we can,
everybody.
in the same way that we can spot repetitive photographs, we'll be able to spot the use of ChatGPT in time for that. Okay, thanks, John. Cheers.
Thank you, everybody. Bye-bye.